Hello class, I just noticed that I mentioned I would go over example 8.9 as well. I was just gonna go and present your homework, but since we really didn't do many of the T distribution, and I did mention on your class note over here that I would also go right here over example 8.9. So that's what we're going to be doing right now. So we're going to be using pretty much the same information that we have used, the same formulas that we have used for example 8.8. Now the difference is you're being asked for a 90% confidence interval. So we're back to this curve right here where I put it for you on a 90% confidence interval. Therefore, you're going to have a 5% for each tail. So 5% on the lower limit or 5% on the tail below the mean and 5% on the upper limit or above the mean. How do I know that? Well, if I get, regardless of this, if I get my alpha, my 100% minus the alpha, which is 90%, I get 10%. But now I'm going to have to divide that value by 2, which is 5%. Right here, 5%. And this is really what I'm going to need. I'm not doing the z-score or using the z distribution, so I'm not going to need anything else. So that's why I put in red right here. I can even highlight it even more. And right here at 90%, so I actually have to change here. I'm gonna have a 0.05. And for my degrees of freedom, let's read the problem. The HTP is working to understand the scope of industrial pollution in the human body. Industrial chemicals may enter the body through pollution or as ingredients in consumer products. In October 2008, the scientists at HTP test cord blood samples for 20 newborn infants in the United States. Therefore, there is my sample size 20. Um, if you keep reading, you're not being given the standard deviation for the problem anywhere if you keep reading. Therefore, we're going to estimate the standard deviation of the sample and use as our standard deviation of the population. Okay, so right here it's giving you the values for the samples, the cord blood samples for 20 newborn infants. It's right here in this little table, which I have listed down here. But let me do this first. 20 is my sample, right? Minus 1 for degrees of freedom. So you're going to have 19. Just to finish what you're going to be looking up at the T table. Okay, let's go back here. I might have got a little ahead of myself. I have these values over here listed on the left are just the values from this table over here. So see how it finished in 99. And then if you go back, and then you have 139, and then 114, and then 123, 144. So really, I just listed all the values here because I'm gonna have to calculate my mean, my standard deviation. We know the sample size is 20. We know the degree of freedom is 20 minus 1, so it's 19. And we know that T at 90%, it's gonna be the 0.05, 5%, correct? From over here. Okay, and then for the error bound margin, we're going to be using this formula, which first we're going to have to get this value from the T distribution table. How do you do that? Open your T distribution table, and it's giving you again, like I said, for the one tail and the two tails. We know that confidence intervals are always going to be a two-tail test. So if you look at two tail and you have a Well, before you even divide, for a two-tail, you really have a 10%, but if you calculate for each tail is a 5%, so everything's in the same column. It's just telling you if you just use it as a two-tail, do 10%. If you just want a one-tail, then divide it. But in this case, since we do 5 and 5 on each side, so is equals 10. Okay. So let's go over here. Let me make it a little. Here you go. So we know is either a 10% for two tail or 5% each tail, and then the degrees of freedom is 19. Why are we using the t distribution again? Is a sample size is smaller than the 30, and we are estimated the standard deviation of the sample size. I mean the standard deviation of the population based on the standard deviation of the sample size. So 19 degrees of freedom, and then you go all the way to right here. Let me make it bigger. Let me see if I can make it bigger enough to see both and that it doesn't move. Okay, 19 degrees of freedom. Okay, at 10 or 5% each tail, 1.729. So right here, I should actually put it 1.729. Okay, what is my mean? Well, I have to average all these values. That's why I listed them here. I don't need to put them in ascending order. Here I do have 20 values, so correct. And it's telling me my average is 127.45. Let's see if that's correct. Equals to the average of these values. It should be 127.45. Here you go. Okay. Now we need to know the standard deviation. Remember I said the formula that you can use it, and now we are using the sample size to estimate we're using the standard deviation of the sample size because we're going to estimate the standard deviation of the population. So the standard deviation of my sample size estimates standard deviation based on a sample. So we're going to use this formula right here, and all you have to do is to select all your values. My standard deviation is 25.96. Let's go to your book. So it says we found the average. Here you go. Here they only rounded to, okay, let me move it. Here you go. My mean is 127.45. My standard deviation is 25.965, which I added a digit over here. Okay, and then it's telling you there are 20 infants in the sample, so n is equals 20, and my degrees of freedom is the sample minus 1, so that's 19 over here. And we estimated that the value for my, by definition, the area to the right of t is 5%, and so the area to the left, 1 minus 5, is 95%. So if you would use a calculator, but you also can go to your table and you're gonna, like I just showed you, and find 1.729 over here. And now it's gonna be as simple as you're gonna be doing this formula over here to calculate your error bound margin, because once you have calculated your error bound margin, you are gonna be able to subtract from the mean to get the lower limit, the lower bound, and then you're gonna add to the mean to get the upper bound. The mean we already know. Let's do equals this value right here. We already know the mean is equals to so equals to this value. Okay. So let's go ahead and calculate your error bound margin, which is gonna be equals to, and then you're gonna have this value, correct? Because this is my T alpha divided by 2 is equivalent to 1.729 times, let me close parentheses, my standard deviation over here divided by the square root of my sample size, full sample size. And then I found my error bound margin over here. So now all I have to do, I'm gonna do the mean minus my error bound margin to find the lower bound, and I'm gonna do the mean plus my error bound margin to find the upper bound. Let me see how many digits they use, and if we are correct, they use 3 digits. So if I round this up, 117.412 is our lower bound, 137.488, which we would make it one more. So let's put this over here. Equals to my lower bound and equals to my upper bound. The way you would do it, you would say your confidence interval is equals to 117.412, 137.488. That's your confidence interval, and 90% confidence level. And then the way they say is we estimate with 90% confidence that the mean number of all target industrial chemicals found in cord blood in the United States is between 117.41 and 137.49, about that, if you would round it. So it's just funny how I don't like it how they do round some to 2 digits and some to 3 digits. So if they're trying to be more precise, but really didn't matter here because your third digit here it's a zero, and that's why they have left the way it was, because it makes no sense to put it like that. And then you would be done with example 8.9. And I just want to go over so you can see with the different confidence level, and you could just do the same thing for 80%, for 98%, 98%, just like we did with the z-score. The difference here, you are going to have to be looking at your degrees of freedom as well, and you're going to be looking at a different table, which is your T distribution. I just showed you this because some tables you're only gonna see one value, and for two tails, and on other tables just one value for one tail. So be careful what value the table is providing to you. Okay, and I hope this helps with the T distribution. For the next video, I'm gonna be looking at a population proportion, and we should be done with chapter 8 for this week. As usual, do not hesitate to email me or to post any questions on Blackboard, and I will address them as fast as I can.